Welcome, everybody, to the American Space Museum. I'm Marquette. We're so glad that you're with us today for a special program with Gary Allgire. Welcome, Gary. How are you,
Thank
my
you.
friend?
Fine. How are you?
Good, good. You've been doing a tour today. He's a docent a couple days a week when he's down here in Florida and not summertime up in Georgia that you
Yes,
enjoy.
that's correct.
Gary, tell us. Gary is going to talk about the Apollo 1 fire. This is the first time in 3 years that Marty Winkle and I have addressed the fire directly. And I want to say hi to Marty. How you doing?
I'm doing good, Mark.
Good. Am I right? We've always talked about the astronauts and their lives in a positive way and never have really delved into the subject of the tragedy because there's so many things written about it. 57 years ago was this horrible night on January 27th, 1967, that when I talk, excuse me, to workers like Marty, who was working not that night particularly, but working on the lunar module for Grumman on Kennedy Space Center, um, it takes people like you back to memories that are hard to get your head around
That's right.
again.
Yeah, and that's why I'm here today is to talk about the Apollo 1 and the difference between the command modules that we have flown in the Apollo program. Most people don't understand when I say we have a Block 1 version and there's a Block 2 version. So we're going to get into detail so you understand why the Block 1s were flown for Apollo 1, and that was the only time we were trying to launch one with astronauts on board. And unfortunately, it was a failure. But
Astronauts did not die during the launch. It was during a dress rehearsal about 10 days before the launch. You can read ad nauseum about all those sorts of things in there. But when I have talked to people that were there, very involved in it, it's you have said to me privately that people around work that you worked with that were involved with it never talked about it
no,
for years later.
no, they never did. And even after Challenger and Columbia, it was never really discussed amongst the worker bees that actually were worked on it. We know it, and we were in a lot of shock when it did happen, and we just never talked about it. I'd worked with Rockwell engineers that were there the night on Apollo 1 and never knew it until I came across a picture of them during this look some stuff up and see a picture of them where actually had been in part of the investigation, but they never said a word about it.
Well, we treat the three tragedies that happened years apart, but in the same
Yeah.
week, as with reverence and celebrating the lives of the people who were lost there. And today we're going to talk about the Apollo 1 fire and these gentlemen here, Ed White on the left, of course, the first American spacewalk sealed him in the annals of space history. Gus Grissom, the second suborbital flight, and then actually helping build the Gemini module. It was called the Gus Mobile because he had such an influence
And
on
he
it.
flew the first one that they didn't launch on the
Yeah,
Gemini.
and then John Young, and then of course rookie sensation really Roger Chaffee, who
Yes.
was super smart, very
Yes.
involved in the Gemini flights as a Capcom and so forth, and he would have been a rising star for sure.
And I found out he actually flew reconnaissance aircraft over Cuba during the Cuban Missile Crisis.
He was the
Yes,
youngest
yeah,
aviator
yeah,
to be on that U-2 spy plane.
yeah,
Yeah, and he was very driven, very driven
very
from
driven.
Grand Rapids, Michigan, and there's a statue in his hometown, also the hometown of Jack Lousma.
Yeah.
So Gary, I'm going to just I've set you up there that this is, uh, I believe, somewhat an emotional thing for you to go over, and we
Yes, it
appreciate
is.
you doing that. But you're going to hear a story like never told about Apollo 1 from the very
Okay.
beginning. So, Gary Allgire, take it away, my friend.
Okay, we're going to step back in time to 1960 during the Eisenhower administration. They had conceived an idea that we would launch. They launched three astronauts and land them on the moon back in 1960. Of course, it never happened until Kennedy was elected in 1961 when he made this famous statement in front of Congress. He said we want to go to the moon by the end of the decade, which authorized NASA. Congress authorized then the start of the Apollo program. And there was a little bit of confusion at the very beginning. NASA put out a request for a proposal for all these contractors to build the Apollo spacecraft. Personally, I thought McDonald's would win because they built the Mercury and the Gemini, and my family worked for McDonald at the time. But it ended up being North American Aviation that won the contract. And they got the contract in 1961. But between 1961 and 62 is when they finally decided how they were going to go land on the moon. And so this next slide, I'm going to address the modes. Now it shows 3 modes here, but there's actually 4. Modes was NASA's version of how they would choose to go to the moon. The one that von Braun really wanted was a direct landing on the moon. There would be no going into orbit. They would launch with one rocket called the Nova, and they would take everybody up there and they would land and then return back to Earth. That was the first mode. The second mode was let me just make sure I got this right here. Mode 2 was Earth orbit rendezvous. What they would do is they would break it up into a multiple set of rocket launches, and they would build the moon lander and the spacecraft in Earth orbit and send it off to the moon, and that would also be a direct landing. Now, they estimated that it may take up to 15 launches to get this to be accomplished. And then the third one was to break it into 2 different launches. The first one would go to the moon, it would directly land on the moon, and then they would send the one with the astronauts behind it, and it would land on the moon near it. But the problem with that is they would have to, the first one landed, had the fuel for the second one. So they had to transfer fuel from the one that landed first to the one with the crew, and then they could launch off the moon. And that again was very, very risky. They didn't know how to do a fuel transfer in orbit, let alone on the moon. And the last one is which one we chose, which is with the version we have here with the lunar lander that would land separately on the moon. And we would do a moon rendezvous and then land. So those were the 4 modes. Now during that time, it took a year for them to decide which mode that they were going to select. But in the meantime, North American Aviation had to start doing some design work. So the first design that they came up with was based on the previous 3 modes, which would be a direct landing. The spacecraft would be designed so it didn't have the capability to do a rendezvous or a docking or do an EVA. And that ended up being the Block 1s. And unfortunately, by the time that they selected the proper mode, North American Aviation had gotten so much work done into it that they decided not to scrap it, but they would fly it. And that would be the first time that they would fly what looked like an Apollo spacecraft, and it would have the 3 astronauts, which ended up being Apollo 1. They didn't want to discard it. There was actually 3 that they brought here to Kennedy Space Center, and one was for the Apollo 1, and the other 2 were Apollo 4 and Apollo 6. So there were only 3 Block 1s that were here. And let's next picture here.
By the way, that's Roman numeral 1.
Yeah.
And then Block 2 becomes Roman numeral 2 for you space geeks out there.
Now this is the proposal. It's a little bit rough. The one over my head is a Nova rocket that von Braun wanted. It actually ends up being a 5-stage rocket.
Wow.
And then you'll see the Saturn, they called it a C5 then, but it's the father of the actual Saturn V. And it's actually a 4-stage, but we don't, when it got down to really actually design it, it came back to a 3-stage. But you can see that it was basically 50 foot in diameter, and it was
The Nova was 50 feet diameter?
Yeah, 50 feet. It weighed, estimated weight was 10 million pounds for the Nova launcher, and then they would need 8 Saturn F1 engines to produce 12 million pounds of thrust to launch it. There was another problem that they had, and one of the reasons they canceled is they didn't have a facility at the time to build that inside. They could build a Saturn V, but they could not build a Saturn or a Nova in Michoud. So that was another good reason to do it. And von Braun really wanted to fly that, but it got to the question was, can you make Kennedy's goal of doing it by the end of the decade? And he realized, no, we can't. It'll be late 70s before they could get this thing to actually make it to the moon.
Gary, this Nova was so serious that they had pads selected for it, correct? Where Play Linda is.
So Play Linda, yeah, they did. There was actually going to be 4 pads on the Kennedy Space Center side. We only built 2. C and D was never actually bought or built.
Okay. All right. We'll continue here.
Okay. Now, at the same time that von Braun was thinking about his Nova rocket, the Russians were looking. Sergei Korolev wanted to go to the moon too, and he had the same concept. He wanted to have one rocket to do all the lifting, and they would launch a Soyuz spacecraft in there, a modified one, and the goal was to launch and have 2 cosmonauts make it to the moon, of which one would come out and walk on the moon for a little bit. They would go back in, and then they would return back to Earth. And their goal was to beat the United States. However, due to the way they launched their vehicles and test their vehicles, Korolev, he ordered 14 N-1 rockets to be built. 4 were built, and all 4, of course, failed. But he knew that they were going to fail, and their approach was, like Dr. Goddard is, for everything we have a failure on, we learn something, and we'll just keep building on that and building on that. And he has stated that the 13th and 14th launch of this N-1 rocket would be the moon rockets, the ones that landed on the moon.
Kind of like we're smacks in my ear to the Starship that Elon Musk is pioneering.
Elon Musk has the same approach. Now, he's got plenty of money, so that's his gig. He can do that. But the Russians, they were running into financial problems, and plus, Sergei Korolev died during that program on an operating table for a minor operation. The person who replaced him was not a good manager, and they finally ended up just dropping the whole program.
Right. Well,
this is the Nova launcher that von Braun won. Like I said, it's 55 feet in diameter. I think it was about 10 foot taller than the Saturn V overall.
Falcon 9's 12 feet in diameter, folks, if you just want a reference there.
And again, this was not designed to do a rendezvous, not to have an EVA. It's based on the Block 1s. And so now, let's see, what's the next picture here?
All righty.
Yeah. Okay. One of the things that I noticed about this, his lander was going to be, 65 feet tall?
Wow.
And, you got almost 13 and a half feet diameter at the service module interface, and 21
feet?
Yeah, at the base. And it had 4 landing legs, just like the lunar module has. But it looked very difficult for the 3 astronauts to get out and break it down to the surface of the moon. So that was another reason, I think, that they decided that this was not a really good approach to landing on the moon. This is a model of it, what it would look like. Unfortunately, they put a Block 2 spacecraft on it, but actually the Block 1s looked a little bit different. And you can see somebody has photoshopped some landing legs from the limb.
Yeah, the limb on there, yeah.
The ones that they were
on a tripod there.
Were much, much taller. And it had 4 J2 engines, and it would land, and then they would use the service module engine to go back to Earth. That white section there, that would stay on the moon, and they would launch off of that after they'd landed.
Interesting concept that I'm not very familiar with there. An Apollo command module, service module, on a landing platform, so to speak.
Yeah.
There, the lunar module of Grumman, Marty. This was 200 feet. What was it, the height of this? Was 65. The lunar module was what, 23 feet high, Marty? Something like
34?
the height off the ground, the windows, let's say.
Well, I should know that, but I think it was 34 feet.
Okay.
Maybe it was 27.
Yeah, so this is twice as tall.
Yeah, exactly. So, well, we're talking with Gary Allgire about the Apollo 1 fire. He was hired a year after the fire in your career as a structural engineer, and he's going to tell you things I think that you probably never heard in this type of perspective from somebody who was involved a year after with this.
Okay.
So, Gary, what are we looking at?
And we're looking at the actual Apollo 1 spacecraft. The changes to it are quite pronounced if you know what you're looking for. Of course, we had the three-piece, it's actually a two-piece hatch that was used. The third piece that was called part of the boost protective cover. So after the launch escape tower was jettisoned, and you're just down to two hatches. But on the ground at the pad, there's actually three hatches that the astronauts have to pass through to get out or go into the spacecraft. What you're looking at there is the side window and the window up just to the right of it. Those are where the commander would sit. Above that, you'll see the cone. Just to the edge of the cone there, you'll see two red circles. That is the pitch engines that are on the Apollo spacecraft.
At the top there,
yeah,
right.
top.
Above your
Now,
head.
they changed that on the Block 2. They went from vertical to horizontal. And then if you come down, you'll see like a shadow, and there's a half moon sticking up on the side of the spacecraft there. Just at the corner of the hatch closest to us. That is a scimitar antenna that was used to, there's one on this side, yeah, right there.
Okay.
There was one here, and then 180 degrees on the other side. There was another one. And these antennas were used when they were in orbit around the Earth. That's how they communicated with the ground stations, with those antennas. For the Block 2s, that was removed and put on a service module instead.
Interesting.
Okay. Now, off to the other side of the hatch that you see, you're going to see what we call a CSM umbilical. I'll talk a little bit more about that.
Right.
Okay.
What are these perforated squares there?
Those are access ports for the getting to the engines, for the pitch engines and the roll engines. Gives them access to those, and they can service them if they needed to service them, or replace them if they were bad. But that's what they were used for. This is the Block 2. You can see it's quite a bit different. You can see above.
I'm guessing that's 14 out of
That's
Space Center.
Apollo 14, and I did work on Apollo 14. You can see that the pitch engines on the top above the hatch are now horizontal,
Right.
way up there.
Yeah.
And then the
Instead
white
of on top of
circulars,
each other.
they have filled it back in, but that is where the drogue chutes are at for on reentry. And off to the right of that, there's a little small circular, white circular thing. That's the pilot chutes. And the pilot chutes, when they come out, they'll pull the main chutes out. So there's three of those.
So it's a canister, the white below the parachute pack there on the top.
It's right next to the parachute. So it will pull the parachute out and deploy the parachute.
Kind of nice they've reconfigured that way for the display, huh?
Yes, it is. It's very nice.
What else does the untrained eye see there?
Well, you can see that the hatch is completely different from what we're going to look at from the Apollo 1 fire. Again, I've talked about this. Earl Homan was the engineer who designed it out of Downey, California. It was a very challenging thing to make it into a one-piece unified hatch. This hatch weighs 390 pounds, whereas the three other hatches on the Apollo Block 1s were 97 pounds. Now, how it's broken down individually, I don't know. I just see the quote that they're 97.
So they tripled the weight of the hatch to make it safer.
They tripled the weight. And to get it open, because it's so heavy, they use GN2 bottles that were pressurized, and they would actually, when they armed one, and then when they went to open, it would open the hatch for them. They could get out instead of 90 seconds under emergency, which I question. They could get out in about 5 to 10 seconds. They could get out. And it's 3 pulls of the handle that they reach up there just over his head. The spacecraft pilot who sits in the center, he would reach up over his head and he would grab a hold of that handle and he would just pull it 3 times, and that hatch would open up.
That's a lot easier than what the Ed White encountered on there.
Yes, it very much
They're going to
is.
explain that.
Okay. This is the CSM umbilical that I pointed out before, and there's 2 major design flaws with this spacecraft.
Now, what spacecraft are we looking at here?
This
Gary?
is Apollo 6 spacecraft. It's up in Fernbank Science Center and outside of Atlanta, Georgia.
And we talked about that last week, the
Yes.
Apollo 6 successful failure. A lot of problems with the Saturn V rocket from Pogo to the S-4B. Didn't ignite to go to the moon. And yet we went to the moon on the next Saturn V all up
correct,
to Apollo 8. But, so interesting. Okay.
Now, this is permanently mounted, whereas the Block 2s, they actually separated and deployed backwards out of the way so they could separate the command module and the service module. I have a picture here on it coming up, but this is permanently mounted, and this is why I consider it a design failure. Is it's directly to the bottom and just to the right of the crew hatch, and so the cables that are coming from the service module, which are your communication lines, some fluid lines, they tied it electrically, or the spacecraft are tied together with the command module service module. They come in, they penetrate into the inner shell of the crew compartment. Because it's located on this side, all those wiring and have to go across the floor. Okay, and we have a picture
in front of the hatch,
and
not on the other side.
The other side. It's off to the side. It's not exactly underneath the hatch, but it's off to the side. So it comes in, makes a couple of bends, and goes down, and then they tied it down on the floor as the cables went across the floor
We'll see pictures of that.
into the instrument portion of the back wall of the spacecraft. Go back to that picture right back there.
Yeah. Okay.
This is after the fire. They're lowering the spacecraft down to take it to we call the payload pyrotechnic installation building, the PIB, which was located about a half mile south of our O&C building and about 100 yards to the east. And that is where they processed the launch escape tower for the shuttle program. For the Apollo program. For the shuttle program, they converted it over to a vertical assembly when they were going to fly payloads vertically out to, and they take them out to the pad. So that's where they would process them there vertically instead of horizontally in their building. And then that building has been torn down now, so there's no way to look at it. But what you're hanging down below,
what is that hanging off the?
That is all the wiring. It's been wrapped to protect it as they come back down. So I don't know where the separation plane was. I wasn't able to crawl underneath the spacecraft at Fernbank. And if I go back there, I want to see if I can get permission to look underneath there, see how those wires were either cut, because I know how we did it on the Block 2s, but this Block 1 was a little bit different.
So you're setting up, and it's critical where those wires were laying in there that
it was a
to fire.
Bad decision to put that umbilical in that location. I don't know what the reason was, because it was before my time here working at
That's
NASA.
a picture I've never seen there.
Yeah.
That was.
But that's lowering it down. Now this is the CSM umbilical. It's on the Block 2s. We hook up all the lines. There's a big guillotine in there, and when they get ready to separate, they'll fire the ordnance, and that will slam down and cut all the electrical lines and any fluid lines.
All the electrical lines coming from the service module, the big cylinder white thing beneath the command module.
Correct.
All of that is going in there. There's telemetry. There's fluids.
Fluids. They got to control the engines, and so all that stuff is being controlled from inside the crew compartment.
That's the connector. Huh?
But it goes directly right into the back wall, which is where all your electronics are at. Okay. And then when they fire that guillotine, it kicks it back out of the way, and it has a locking feature, so it locks it in the open position. So it doesn't interfere with the separation of the command module to the service module. They fire again. There's 3 bolts that hold the two together. They have explosive nuts. They fire those nuts, and then they'll separate. And whatever's sticking out will be burned off as they re-enter the atmosphere.
Interesting. But here's the
So here's the layout of Apollo 6 wiring. You can see the wiring house that goes across to the floor to the instrument bay. Now for Apollo 1, I never had the opportunity to go in and look at that flooring, and I never did. And so I don't know, there was probably some rerouting a little bit different because they had stowage lockers underneath their couches.
So this is before the couches were put in,
Yeah.
structures like that. But you're saying these snake lines right off your shoulder there, coming from the outside,
From the CSM
right beside the
umbilical.
hatch.
Yes. I mean, and that is the reason really we had the fire, because what we've heard is that Gus Grissom got out of his couch, he stepped on one of those connectors and generated the spark, which caused the fire. Of course, we all know about the hatch, and we'll talk about that. But there was 2 other contributing factors to this fire. One, obviously, is the pure oxygen environment, and the second one is the walls. The astronauts discovered Velcro, and they lined the walls. Everywhere they could put Velcro, they put it, because they just knew when you get in orbit, 0G, they'd just throw something and it would stick against the wall, and they knew where it was at. They didn't have to go search for it. And then after the fire, we eliminated almost 99% of that.
Really?
It was very controlled. We only could put so many square inches and so many square feet.
Because it was flammable.
It was flammable, yes.
Couldn't make non-flammable Velcro?
No, well, not at that time. Maybe today they can, but back
Did
in,
not know that. We're talking with Gary Allgire about the Apollo 1 fire, him being a structural engineer that a year later was hired after the fire and then worked on the Block 2 Apollo command modules. Just, I'm reminded of our friend Marty Winkle running the Streamlabs board there. He wired the lunar module and did things like that. It's neat, to the untrained eye. I've seen the manuals and so forth. Every little tie down there is inspected by a NASA inspector that watches the technician do it, correct?
Yeah, quality inspector and a NASA inspector, and probably a couple engineers.
Yeah,
But
so
the
when you
question-
look at this, a lot of minds and eyes were on this to put everything right there.
And the question I always had is, why we didn't put wire tray covers over them, so that if they stepped on them, they wouldn't do any damage. And you cannot, it sits in the altitude chamber for maybe a couple of months, and out at the VAB for a month, and out at the pad for a month or so normally. And there's technicians going in and out all the time, carrying equipment and stuff, and they're stepping all over that. So they have a tendency, they try to miss it, but they can't. And so over time, you wear those connectors and those electric connections, you wear them down a little bit. So it doesn't surprise me that they had a spark from it when they stepped on it.
We've got a question for Gary, Marty, on our UCX family microphone.
Gary, didn't they have a GSE floor over the cables?
No.
It was just the cables were exposed?
Yes.
Crazy.
That's my understanding.
Okay. Here's our beautiful backdrop here of the command module.
This is the
controls.
instrument panel that the astronauts look at. The commander is on the left. The spacecraft pilot is in the middle seat, and then the lunar module pilot is in the right-hand seat. The lunar module works with the commander when they land on the moon. Buzz Aldrin is set on the right-hand side, and Neil Armstrong would be in the left seat, and Michael Collins would be in the other. Now, Michael Collins' main deal he has to do is not only operate the command module while they're in orbit and do experiments and photography, but on re-entry, if the guidance system fails, he has to manually bring in the spacecraft on his own. The commander does not do it. It's the spacecraft pilot that will land if there's a failure in the guidance system.
Hmm.
Because he's the only one that can look up over his head, and he'll see that big window in that hatch, and there's lines on there that mean something to him. To me, there's spaghetti, but what he's doing is he's lining the Earth's horizon at certain points. Actually, when they come in heat shield first and heads up upside down, and then they'll come in and they'll hit at a very light angle, and then a little bit later they'll come up a little bit, and before they make the big dive down. And that is to cool off the heat shield a little bit. To do that.
Very, very good deal. I did not know that the pilot took over manual control on a reentry on all the Apollos.
Yeah, he's got a rotation hand controller. It's on his right hand side, and that's what he would use, the pitch, roll, and yaw to guide the spacecraft in. So he's a very important man when it went to come back if the guidance system fails. I don't know if they ever had to do that, but they were prepared for it.
Absolutely. All right.
In the center there, let's go back just a little bit.
Just take that off there.
In the center there, you'll see kind of a cutout in the instrument panel. If you stood there and you look straight up, that would be the tunnel, and there'd be the tunnel hatch right above you.
Right in here.
No, yeah, right there. Yeah, right in there.
Point your hand in there.
It's right here.
There you go.
Okay, and right there behind it, let me get over. It goes off screen.
You lose your hand.
The tan area that's the star tracker and the telescope.
Okay.
They use the star tracker to set up their alignments. And if we talked about Apollo 13, I'll talk a little bit more about the difficulties they had on Apollo 13 with that. And then you have on the left instrument panels on the sides they have other switches and stuff for circuit breakers and so forth.
Right.
Okay.
Very complicated.
A lot of switches.
Yeah, I forget. Marty, how many switches in the lamp? You remember?
I want to say 500. It was either 500 or 300 switches, dials, instrumentation.
Command modules easily got twice that in there.
Now, this is the Apollo 1 crew going into our altitude chamber, and this is they're going to be doing an altitude run. They're going to pump the chamber down. Once everybody's out and the lid's on, they will pump it to equivalent to a 200,000 feet altitude.
Now, where was this performed at?
This was performed in the O&C, or Operation and Checkout Building, just next door to the headquarters building. Okay, there was two chambers, one for us and one for the lunar module. And again, they would do the same test during the normal Apollo mission. They would also do an altitude run with the lunar module.
So they simulate the space environment here on Earth in a big room.
Yes.
That they take all the air out and make it cold and hot on one side. And all.
No, they don't do that. The radiators will generate a lot of heat, and they have other radiators that come up against it, absorbing that heat that's coming off the spacecraft radiators to keep things under control. But they didn't. All he did was just do a vacuum run.
Okay.
And that's just basically to checking out all the seals work and there's no leaks. And then of course they do all they go through a launch environment type thing. Let's go back to the chamber. Now the three crewmen there, the first one coming out and going in is probably Gus Grissom. He would slide in until he would go into the left seat to him. Then after that would be Roger Chaffee. He would come in and he would go into the right-hand seat. And then the last person standing off there on the left, that it would be Ed White. Okay. Mm-hmm. And then off to the left, there's a toolbox. That was all the tools that ever goes inside that spacecraft had to come out of that toolbox. It couldn't take anybody else's homemade stuff into this spacecraft. We had to check it out. We had to sign a name to it, clock it out, what time we clocked it out, and what time we brought it back. And most of the stuff was tethered, if we could tether. Off to the back side there was a door, and it led to an anteroom where when we went up there, we had smocks on, but if we wanted to go inside the spacecraft, we had to go full bunny suit. So we would go in this anteroom, and that's where we would change over from smocks to bunny suits.
So you're very familiar with this altitude chamber.
Oh, yeah. Been there many times. And then if you continue on, there's another door It's open. It brings you out to the third floor hallway, and to their left would be the astronaut quarters, and to the right we had two control rooms for the Apollo spacecraft and for the lunar module. They were small rooms, and that's where we would do all the testing. All the engineers would sit, and we had a test conductor there, and George Page would be in there, and he would be running that show. So that was how we did it. But the astronauts would come through those doors. Down at the base, there's another big door which you open up, and that's where we normally would come in through if we're doing our day-to-day business.
Fascinating facts from someone who was there, Gary Allgire. We're talking about the Apollo 1 fire, January 27th, 1967, 57 years ago this weekend. And tributes will be had around the Space Coast, and our American Space Museum with the city of Titusville will be honoring our fallen heroes on Sunday, January 28th at Spaceview Park.
Okay.
I mean, Sandpoint Park, not Spaceview Park. So we're continuing here. Gary,
This is in the altitude chamber. This is after the crew. This is a picture of them inside the Apollo 1 spacecraft. They have this blue protective cover that they put over the actual opening to protect the seals. And they hadn't put the hatch on. If they're going to put the hatches on, then they would remove that blue outer ring, and then they would put the command module inner hatch in, and then they would put the outer hatch in. Now, the boost protective hatch would not be here at the time because there's no launch escape tower. So we hadn't put it on yet. But those are the three sitting in there with their helmets on.
Now, when was this altitude chamber test in relation to the tragedy?
It'd be during, I don't know how many months they stayed in the altitude chamber. It may have been 1, 2, maybe 3 months before they actually got to the pad.
Okay.
After we finished those tests and some other tests that the engineers wanted to do with the guidance systems and communications, they would take it out, put the nozzle on the service module, and then they would stack it on a trailer, and they would take it out to pad 34, where they would lift it up and put it on the launch vehicle. There was no slaw, basically, for the lunar module on this first mission.
Okay. See, the last Apollo, or last Gemini flight, Gemini 12, was November 66. Here, this tragedy happened in January 67. So all this was going on in parallel to the end of the Gemini program.
Yeah, and I point out the Gemini program was really key to this launching going to the moon, because to do that we had to solve a lot of issues. We had to do a spacewalk. We had to prove that we could stay in space for 8 days, which they did. Mm-hmm. Actually, they went up to 14 days. They had to show that they could work outside the cabin, which they finally did with Buzz Aldrin on his last Gemini flight. They had to do a rendezvous and a docking. We had to prove all that, and once we did that, then we had the confidence that we could go to the moon.
And with that confidence was this spacecraft was going to take us there in some form. Let's look at the details now of that hatch.
This is a cutaway, a sketch of the hatches. You can see the 3 hatches here. The boost protective cover is shown. Well, the one on the bottom left is actually just a framework that's there. So you had your boost protective hatch at the bottom right, then you had the actual outer shell hatch, and then you have the inner shell hatch, which is the one that had to be go in and then come back out, and it would seal by pressure against that ring, and that would assure the crew that the hatch was not going to open up on them in orbit. This is really leads back to Gus Grissom's second, when they did the second suborbital flight, when this hatch, which was for the first one that ever had an explosive hatch, and it blew before he was ready to get out. And
in the water, while he was in the ocean.
In the water, and he knew he had not triggered the hatch. The press got word, and they thought they put out that he panicked, and he panicked and he fired the hatch before he was ready. The problem was he had just taken his helmet off, and he had not sealed around his neck. So when that hatch blew, which surprised him, water started coming into the compartment. He crawled out and got in the water, and because he hadn't sealed it, water started going into his suit, and he almost drowned.
Very lucky.
He was very lucky when they pulled him out, because it wasn't much longer, and that suit would have pulled him down in 12,000 feet of water. So
and suspected triggered the pyros was
they don't really know. They just know that he didn't do it.
Yeah,
and
heard it may have been the helicopter rotors.
No, it was not there yet. They were still coming up to it.
Okay.
And when it blew,
urban legend there.
They did find his capsule in 12,000 feet of water. They pulled it out, retrieved it, cleaned it up, and looked at the controller that would fire that hatch off, and it was in the proper position. So he never got the satisfaction of clearing his name with the press corps.
And you can see that Mercury spacecraft at the Cosmosphere in Kansas.
Okay.
I've seen it, and he took a bunch of Mercury dimes with him.
Oh, really?
Rolls of Mercury dimes they took with them was under the seat. All right, they showed those there to get Mercury dimes, or you maybe never held one in your hand if you're under 40 years old.
Yeah,
but Mercury spacecraft, Mercury dimes he was going to give out.
This is okay. This is the actual hatches that you can see up there at the Visitor Space Center. The one on the left is the boost protective hatch. It's not very clear because it has a lot of smudge marks on it, but that is the outer crew compartment hatch. And then you have the inner hatch that you see there, and that's looking as though you're on the outside of the spacecraft. You have 6 latches that are ganged together, and then I think we can go to another picture here. This is what it looks like on the inside. We don't have actual picture of the inside of that. It had 2 handles, and you see that circular device there. What he had to do is, if he wanted to get out, or if they wanted to get out, they would have a ratchet wrench in the compartment. He'd have to pull it out, stick it in that hole, and then he could rotate it counterclockwise, and that would open up the 6 latches. And then
we're going to show you where all that's located in a very famous picture you've seen 1,000 times.
And in the meantime, it also opened up a pressure relief valve, and that equalized the pressure between the inside cabin and to the outside hatch, that little volume. So it equalized it. So now he could pull the hatch off. He could lower it down to below his couch, and then he would have to go in and, using that same tool, open up the next hatch. Okay, that's what he would have to do. Here's a depiction of him showing. This is and with the handle. It's got a lanyard on it, and this is what he would use to open it. It was the responsibility of the senior pilot, which was Ed White. He was a very, very strong person, but evidently he could not overcome the pressure that built up in there. But this is the hatch he would have to open. This is actually the outside of it. Again, in between if you look at the 6 latches, if you look at the very center, you'll see that silver thing with a little hole in it. That's where the crew on the outside, if they was going to open the hatch, they'd put that tool in, rotate it counterclockwise, or that would clockwise, I guess, with them, and then they would open it up.
Marty, we have a question for Gary Allgire.
Yeah, we got a question from Mark, if I pronounce his last name correctly, Warabets. Gary, do you think the Apollo 1 spacecraft should be put on display?
Gus Grissom's brother,
Lowell,
really wanted to do something. He wanted to have the remains of the capsule and put into the same silo that the Challenger's at. And right now, it's sitting inside a container in a building at Langley Research Center.
At what research center?
Langley.
Langley, okay.
Yeah. It originally was outside. When I first came to NASA, my lead engineer at that time, Bill Beaker, showed me a photograph of it, saying this is where it was at. because I did ask, I said, where's the spacecraft? And he showed me the picture, and it was outside the building. And it sat out there for many years until he finally put it inside.
Uncovered?
No, it was in a container.
Oh, okay.
Same container, yeah.
Interesting.
So
Is there research value to it 50
well,
years later?
it's not in one piece. It's been separated. I'll show you here later, but it's been pulled apart. And they did a lot of investigation, so it really is something
That's the original hatch there.
That is this is the next hatch he has to go through. Now, up there you'll see a yellow button.
I do at the upper right.
He had to slap that, and that would release the boost protective cover, and it would fall away.
Aha.
Well, sort of. It would. He had to. There's a handle. It's very hard to see off to the left. It's brown or tan. I don't know if Marty, can you keep going all the way up to the top?
Oh,
right,
I see it. Yeah.
right there. That's lever. A quick release to release the boost protective hatch.
Like a pole.
Yeah, just pull it, and it would release the. It's connected to the mechanism that would release the boost protective cover hatch. As far as I can been able to determine, none of these were hinged. Okay.
Interesting.
Now let's go back. Let's go back again. Up there at the very top above the window, there's another circular device. That's where he would put the other. Just right there. He would put that ratchet handle in there, and he would drive it and open up all the other latches, and it would fall forward out of the way.
So there's an interior latch, the next latch. He's got to stick it 3 times. You've got to put the same ratchet in.
Well, just twice, just for the inner one and the next outer one that we see right here, and then the next one. He's got that lever it pulls that will release it, but then the other thing, he punches that yellow one, and that kicks it off. Okay. Now this is I think this is back in the altitude chamber, getting ready to do the run. You can see the crew technicians trying to install that hatch. They have to dip it inside to kind of bring it around and pull it back, and then it took 2 people to do this. You can see one guy to operate the ratchet handle, and the other one guy to hold both handles to then rotate it and pull it back up and seat it, and then they would latch it.
So the question is, how can one astronaut laying on his back do that when it takes 2 men to?
Yeah, that's a good question, and I'm going to address that. This is in a engineering mock-up that they would practice in. They're fully suited up. Above that, you'll see this little red arrow.
See this red arrow?
Yeah.
Yes.
Now, it's pointing to a little lanyard. What he would have to do, Ed White would have to reach up over his head and pull that lanyard to open up that pouch. The next picture will show a little bit better definition of it. You can see it there. It shows up a little bit better here.
The pouch, the black little strip down there. He's got to pull that.
Pull it up, and that's where the tool would be sitting. So he'd have to get that tool out, and then he can. And before if he's going to open it from inside, he has to lift that bag up. If it may have been Velcroed, I don't know. If it's Velcro, he could just rip it off.
So but under the bag is
would be the access point.
Now, in this picture, for Ed to do that, he had to do a disconnect of his hoses, right?
Yes. There's a sequence of events. I don't know. Let's go to the next one here. This is a Block 2 couches. I don't know how much difference they were between the Block 1. I'm assuming that they're pretty close to it. What you're looking at here is the commander's seat. And then in the center,
of course, they're not in a spacecraft because there's furniture drawers beneath in there.
Yeah. I've circled the three items that they need to work.
Right there.
Okay. Yeah.
Above me.
The one above you, the top one, is a thing that he squeezes, and that allows him to lower the hand controller out of the way. It either folds it come back, or he can fold it down.
That's the square box, the gray box.
Yeah,
there.
That's the translation hand controller. Rotation hand controller is the next one over, and that also has the same thing. Now the lever directly below that, the fancy looking one, what we do is that would drop the seat pan down, or it can fold it back up against the backrest, the back seat. And then the other one that's
Above your head.
it's above my head. That is to lower the calf pan, yeah, back underneath the seat pan, and then you have the footrest would fold up out of the way. If they wanted to do, they could lay it flat, sleep on it if they wanted to, or they could take them. They can disconnect them from the framework that it's sitting in and stow them to give them some little bit more room. It depends on what they wanted to do. Now, the couches are suspended by 4 struts, and then there's above my head is another set of struts right there, and I've overlaid what the stroke is. These were like a motorcycle fork tube. I don't know if you're familiar with that. You had a larger diameter tube and a smaller diameter tube, and the larger one was the one that the inner one was attached to the ceiling of the command module, and the outer one was not. And so if it was going to land on land, they really needed this because it would absorb some of the impact fields. They thought that they would have to use it during water landings, but I understand that they never stroke. There was a lanyard and a hook that held the two together. And once they were on the chutes, then they would pull this lanyard, which would release them. And the reason they did that is they were not tied together. So if they stroked it long enough, the inner tube, the outer tube would come out, and the inner tube would be sitting there dangling, and it'd be on the ground. And so it was a very, very unique design that George Campbell came up with to absorb it. It's all mechanical. It has nothing to do with fluids or springs or anything like that. But this is how they did it. Now, you can see right here, right where it says hex XX, head XX. You see that black line? Right behind that black line is a silhouette of the new unified hatch. And so you can see all he had to do is reach up there and pull that handle.
The little arrows pointing to the 3 pump.
Yeah. Well, it's
armor,
actually
right?
pointing to the struts, but it's right
No,
there.
the little one. You've got a little one. The big one's pointing to the strut.
Oh yeah, they got a little
But you've
one.
got
I'm
a
sorry,
little
yeah, the
one
little
there.
one. The little one's pointing strictly to the hand.
Yeah. And you
hands-
said 3 pumps and it's over.
3 pumps to open it, and I think it was 6 pumps to close it. This is how it worked. They called the inner tube had bracelets slid on it. Now the inner tube and the outer tube diameters, the diameters were such fact that on each little bracelet, which is the yellow thing up in the corner, it had all kinds of little bracelets around it. And I think back then, I don't remember years when the girls would have these little bracelets with the spinners on them all the way around. And they had letters on them. They could move around. Well, they had this, and they had little cut grooves in them all the way around. It looked like a tank track, really. And what it was is that diameter of that blue item was larger than the spacing between the two tubes. So when they put it together, it actually had to crush an ovalite, making it into an oval as they put it together. And what it was...
Yeah, go ahead.
Okay, what it deals with, as it stroked, those little ringlets would roll, and that took energy, and that's what absorbed the shock of a hard landing.
Wow, what an interesting concept that is.
Yeah.
Get you a drink of water there, Gary. You're doing an awesome job. Marty's got a question here from somebody watching this fascinating program today.
Yeah, question from Dave Stange. Was the Apollo 1 hatch just mentioned for the Block 1 capsule only, and then they had already designed a new hatch to be used in the Block 2 capsule?
I don't know. I didn't talk to Earl and ask him exactly when he started the design. When they went to the mode that we know about today, they knew that they would have to design a docking system and that they were going to do an EVA. I don't know whether they were unhappy with the design, but they designed it. When Apollo 4 launched, we did not have a hatch to put in there. So what they did is they took the window out and they put in the seals that would be used on this new unified hatch. and some other material. But when we got to to Apollo 6, we had the hatch was built, and so we flew a Block 2 hatch on a Block 1 spacecraft for Apollo 6.
Unmanned, uncrewed, of course.
Uncrewed, yeah, just to verify the integrity of it. I don't know if I hope that answers his question.
Thank you for your question there, Dave
Yeah.
Stang. He's watching up in Michigan.
Yeah.
Should we tell him it's going to be 80s this weekend, Marty? I guess. Nah, we won't tell
Okay.
you that, okay?
If you do, then I'll talk about the Lions.
Oh,
Yeah, right. He's a Detroit Lion fan, I'm sure, up there. We're down to just 3 more football games
Okay.
left in the NFL. Well, we've really enjoyed this, Gary. You've really made it clear about this hatch. And here we're ending our program with some of the photographs of the tragedy. And so,
can we really quickly go back to where we show the couch off the right there? Yes. This is
Okay.
the position that they would have been in when the fire started, except for Gus Grissom, who was out of the hatch, and he had lowered the seat pan down
now there were no cameras in there. How did we know he was out of this couch?
because the couch. Can we go to?
Yeah.
Let's see.
If I'm jumping ahead here.
We're
but-
going to jump ahead here.
okay. Well, there's a reason why we know what he was doing.
Okay.
So,
Keep going.
all right, I will go to the.
This let's go one more time. Okay, this is aftermath after they pull the crew out. I notice, I don't know if you will notice it, but Ed White's seat pan is in its proper position. I can see the foot pans that his feet sat in.
This is all way up in the background, back in the top up
Yeah,
there.
at the
right?
very, very top.
Point to it.
Yeah. Come over to the right just a little bit.
Isn't that it?
No, that's right there. That's the foot pans that are out. And
Okay,
so,
those are the foot pans that
so
we're
he's
showing
he's lying on
right
his back.
there where his feet are.
Yeah, he's lying on his back in this position. Now, if you go back and look at the left side, you cannot see any
Foot pan there.
foot pans there, and you can see that I can see back into the crew compartment. So his seat is down. To get out,
Gus's seat.
yeah, to get up, he has to lower that. He can't not get out without doing that out of his seat. Also, his headrest off there in the bottom left corner, the two arms that support his helmet are folded back in. So he was not in his couch. Now to get them out, and also to get them out, you'll notice that the oxygen hoses, they have been cut. So they did not have the time to disconnect their hoses to get out. Now Ed White would have had to go on and turn over because he cannot, with his helmet on, he would have a very difficult time feeling for that tool in there,
Pulling the hat thing.
pulling the thing out.
Mm.
So for him to turn around, he would have to probably drop his seat pan down so he could roll over onto his belly, reach up and grab that tool, and then operate. Now he's at a disadvantage because he's laying on his belly to pull that hatch back off. The report was the pressure built up to 20 atmospheres, almost I think 20, almost 30 psi. There's no way he's going to pull that off. It was so high that it actually ruptured the inner module. And that's what you saw on a previous with the burn marks, where it came out all those access ports that were open. So those were the burn marks that they saw when it came out.
Which is this picture back here.
Yeah, that's the picture right there.
Yeah.
You can see the boost protective cover just off to the left where the white room is, and then the launch escape tower is on top. And it probably was in this area because that's the darkest area I see of a suit that's up out of that one hole that's open, or a panel that's been off.
Uh-huh.
So when that relieved, then that dropped the pressure inside. If they could have gotten that hatch open and there was somebody standing out front of that hatch with the 20 psi pressure, when he released that thing, it would have flown out, and who was ever standing there would have probably been killed with that high of pressure. But there was nobody in the white room at the time of the fire. There was
All right.
nothing they could do about it. They had to wait till it cooled down before they could get back in there.
The escape tower was active, correct? With propellants?
It wasn't armed. It was it had a
Not
bullet,
active, but it had propellants.
It had propellants in it, and it was not armed.
I mean, as horrible as this tragedy was, it could have been a lot worse.
Yeah, we almost had one of those happen to us on a shuttle program. We almost dropped an IUS.
Really?
Yeah,
Yikes. Tell me about that later.
I will.
All right, I'm sure you
Yeah.
will. Well,
Okay.
there's some detail of that.
So this, like I said, this is after facts, after they removed the crew. And we do know they were fully suited and they had their helmets closed. This is after the fire. They wrapped the spacecraft in this Mylar blanket and dismantled it here and lifted up. And that first picture we saw early in the show, that was it being lowered down onto a transporter to take to this building right here, which is the Pyrotechnics Installation Building below, just south of our offices.
See the top cone above your
The
head
top
there
cone.
taken off.
The outer heat shield has been removed, and this is the inner side. And so they wanted to do a complete investigation of that. And then you can see the outer shell sitting there. You can see where the hatch was. And the bottom heat shield is up there on the top of the picture.
Amazing photograph
Yeah.
there.
And then they boxed it up in this and called it Apollo 1. I don't believe it came to Kennedy with this container. If it did, it didn't have Apollo 1 because they named it Apollo 1 after the fire, I think, by the technicians. They wanted to call it Apollo 1.
Huh.
And this is in the container that's inside of a building. And this is where its final resting place is right now at Langley Research Center.
My. 57 years ago.
Yeah. And this is the new unified hatch. This is the actual one that was flown on Apollo 6. It's not with the Apollo 6 spacecraft. The museum would love to have it on display. This picture was taken when I guess it had been shipped over to Japan and was on display there. You can see the white electrical cords. Those are part of the instrumentation that they would use to monitor it for the first time we flew it to see how it performed. Basically looking at temperatures, thermal temperatures, shock loading, and so forth like that.
Well, if you want to put your hand on a Block 2 hatch like this, go to the Frontiers of Flight Museum at Love Field in Dallas.
Oh, yeah.
They have Apollo 7 there. And when I was there, the hatch is open and there's a step to get to stand up there. And I looked at the docent and I go, I can go up here and put my hands on this? He says, you have at it.
Yeah.
They let you put your hands all over the outside of the spacecraft. There's just a velvet rope around it.
Oh.
Of course, they have a plastic in front of the hatch itself so you can't get inside the thing,
Yeah.
which I would have crawled in and done if I could. But yeah, it's the only spacecraft I've been around that you can touch there.
Yeah, that's good.
At Love Field there, Frontiers of Flight. That should be on your bucket list. All kinds of aviation
And there's no
things
reason
there.
why you couldn't touch it. I mean, you're not going to hurt it. It's
Right.
pretty. It's pretty stout.
Well, Gary, what an excellent program today. We hope everybody's enjoyed it today. We've got Marty's written down a couple new people. Nick Sedler. Hope that you've enjoyed this, Nick, and tell your friends about our podcast that we do Monday through Friday. Mark Warabetz. Thank you, Mark Warabetz, for watching. Carlton Bailey's watching today from his hacienda out there in Cape Canaveral Groves.
Oh,
Is where
I know that is.
Canaveral Groves is where Carlton's at. Tom Celentano, probably a little chilly up there in Connecticut. Bill Whiting's up in Michigan, or is he back yet? We'll hope to see.
He's still up there.
All right. Hurry back down, Bill. The astronaut group is waiting for you there. We've got 6 or 7 women this next quarter coming out there. That'll be awesome to talk to. Steve Jokums is from the Lake County Spaceport up there in Illinois. It's probably frozen in at the moment off Lake Michigan. Doug Forrest is staying warm in Los Angeles. Dougie, go take a snap of the Endeavor out there next to you and send it to us. Cliff Watson's enjoying summer in Pomona, Australia. Thank you for watching, Cliffy. Tom Usiak is watching in Pennsylvania. Gary Gerald's in Collins, Georgia. He's our Fidelia farmer up there. And Cynthia Rossi, thank you, young lady, for watching. Dave Stangy, thank you for your question. And Mark Usiak is watching in Lancaster with, he's probably not watching with his big brother, but they're hanging out there in Pennsylvania together. So thank you for a great program, Marty. A good Streamlabs job today. Gary, you have anything else you'd like to add? You did an excellent job on a tough subject.
It is tough, and then we're going to come back and talk Challenger and talk Columbia. And the reason I do these is for the future engineers. We don't want to repeat what we went through, and it's very important that you spend time to analyze what you're working with, especially ergonomics. I think if they would go back and look at Apollo 1 spacecraft, they would have never probably really would have flown that based on the fact that they really couldn't have got out. Never thought there would be a fire, but those things do happen. So you have to really be prepared for something like that. And it's very, very important that we as engineers, that we properly do our job. We were told, we came to work for NASA, that if you made a mistake and you broke something or whatever, you don't hide it. You tell people about it. You won't get fired. You just got to know.
Quite a culture, too.
Yes,
It's quite a culture there. Promptly admit that you've done something wrong so it doesn't affect something down the line that could be innocuously affected by that.
Our goal is to have complete trust of the astronauts when they get inside that spacecraft. And so we have documentation to help us provide that trust for them. Plus, we try to maintain a very professional rapport with the astronauts. We don't go around and bug them for autographs or anything like that. We let them do their job. And if they come and ask us something, then we'll answer it. But we don't go out of the way and say, hey, you got a problem over here, because we really didn't have any problem that they needed to worry about.
Well, it's engineers like you, Gary, and all the contractors of NASA, like Marty, that did get the trust of those astronauts to go to the moon 50 years ago and land 6 times, and then to 134 successful missions of our shuttle to build the International Space Station.
And Grumman Engineering, their technicians, North American Aviation, which came Rockwell, and their technicians and engineers were all a great group of people.
Well, you've dealt with all of them, so that's from the facts there. So, Gary, thank you very much again.
Okay,
we will see Gary on Thursday to talk about Challenger. He was involved with that quite heavily. This gentleman knows a lot about all of the successes as well as the tragedies, and we've had him on now for over a year sharing these. Wednesday, tomorrow, we're going to have Terry White, the chief of the orbital processing facilities. Terry's going to do a special appearance. He comes on once a month to talk about the shuttle garage. He'll be talking about Columbia, specifically some of the recovery efforts of bringing Columbia home. Friday, we'll have the author of bringing Columbia home, Mike Leinbach, the launch director that launched Columbia and 30-some other shuttles. He going to do a question and answer. Y'all watching today, Mike Leinbach loves to take your questions on Friday. Communicate with Mike already, and he's anxious to do another Stay Curious appearance and just tell it like it is, okay? Like he always does. So got a great week planned for you, so please come back and watch Stay Curious and tell your friends that this is the only place where they can get stories like this from Gary Allgire and about the Apollo 1 fire. Until tomorrow, I'm Mark Marquette saying we can't wait to see you again to bridge the space between us. Thank you for watching.